Hi, this is Valerio Lanieri, and together with my colleague Mlađo Milunović, I have realized a project which consisted in the realization of a video game by programming an FPGA board. Specifically, we did program an Nexus 4 board using the VHDL language, and the whole project was performed using the Xilinx ISE platform. This was done as part of the computer architecture class held by Professor Paolo Montuschi at Politecnico School of Turin during the academic year 2014-2015. Here you can see the top schematics for our project, and although it looks monstrous from afar, what me and Mlađo tried to do was to keep it as simple as possible in terms of modules and the way they are interfaced with each other. And of course, we hope we did succeed. So first of all, I wanted to show you the some inputs of our project, and here on the left side you can see, let me zoom in a little bit more, you can see the buttons input. These are connected to the buttons of the FPGA board so that we could actually play the video game while the keyboard was not, the keyboard module was not yet ready. Here you have the PS2 clock input that basically tells our board when it's the right time, our FPGA board, when it's the right time to acquire the signal coming from the keyboard. And here you have the PS2 data input, that is basically the actual signal coming from the keyboard when a button is pressed. So secondly, I want to talk to you about the way the signals coming from the keyboard are acquired by the board. Let me find the right module. Here you can see the module used to acquire the bit sequence and translate it into an actual instruction. So here you can see the single bit entering from the outside, being put together in this module and then being sent to the top module or project as a set of bits that results in an actual instruction being executed. Here, as you can see, we have several modules that several schematics actually resulting in that receive as input our set of instructions, our set of bits that define a certain instruction, and then actually execute it gameplay wise. That is, they send certain variable changes within the pixel generating module, so that the player's ship is told to, for instance, move left or right or up or down or shoot. And this module actually was the trickiest to program, of course, since it really contains the core of our video game. What me and Mlađo tried to do was to keep this part very simple by exploiting a lot procedures, and by writing a lengthy package containing the shape of the enemies to be displayed on screen, and information concerning their colors and the shape of the bullets, etc., etc. And here you can see as outputs blue, green, and red. These are outputs being sent directly to the VGA controller, which is synced to a regular 60 Hz LCD screen. And this is the module doing what I just said. Basically, this module does nothing but syncing the board's internal clock, 100 MHz clock, to the 60 Hz clock of a regular LCD screen, and sends out the actual commands to the VGA controller. And Here you can see the clock diff module. This was used, as I said just now, to divide the internal clock of our board so that it could meet our needs in terms of frequency, of course, since a regular SD screen has a 60 Hz refresh rate, and the PS2 keyboard exploits a 10 kHz internal clock to communicate with the external world. And finally, I want to talk to you about the 7-segment LED display that controls the LED display on our FPGA board. And basically here several digits are required in terms of I don't know, they could be the score, or the number of hit points left, or the number of bullets left, and then they are sent as a signal to the LED controller, so that the right anode could be lit up at the right moment to display the wanted digit. Now I'm gonna give you a brief overlook of the FPGA board and the functionalities we have used. So now the board is turned off. As soon as I turn it on, the pen drive delivers via the USB connection the program of the video game. That is the bit file stored in the USB drive. In a while we'll see the two LED panels turning on. This one on the left shows the bullets left to be shot to the enemies. This one shows the hit points the player has left, and by sliding this switch here, you'll see on the left the number of enemies that have been killed. Of course, now it's set to 0 since the game hasn't started yet. Now, by attaching the keyboard, the red light basically signals now that either no keyboard is connected or that there is some fallacy in the keyboard. But luckily, my keyboard is perfectly working, so the light turns green, meaning that the connection has been successful. And now the game starts by pressing the 1 button, and the 1, 2, and 3 buttons are also associated to the shooting of bullets, so that when I press it again, you will see the number of bullets decreasing. And as you can see, the game has started. As the game has started, the number of hit points decreases as the enemies reach the bottom of the screen. This is the starting screen that you see right after you have loaded our video game on the FPGA board. Then by pressing 1, you begin the game, and the goal is to shoot the right missile at each enemy ship to destroy them. And each time you hit a ship, you lose a bullet, but gain +1 on your score. As you can see, if you shoot the wrong missile, the ship won't get destroyed. And every time a ship reaches the bottom of the screen, you will lose a hit point. Now, since we noticed that the players tend to run out of bullets halfway through an enemy wave, we have decided to add a bonus section which will allow the player to replenish his bullet stock. Another thing I would like to point out is that Mlađo took care of generating a random enemy generator, so that the enemy would appear randomly at the top of the screen, of course having a random color. As I might have previously pointed out, all these shapes are all stored in the package file containing a series of constants. They're more easily called by the pixel generating module. And now I want to show you what happens when the game ends. That is, when the player runs out of hit points. You see a game over screen is being shown. And here on the board, you can see on the right panel the number of hit points left. There is 0 on the left, the number of bullets left at the end of the game, and if you move the slider, as I've shown you before, you can see the number of enemies that I have killed. So this is all. I really hope you have enjoyed this presentation as much as we did enjoy working on this project. Ciao!